The alternative to the linear economy is the circular economy.
Is this idea that everything that you produce goes back into the system, so there is no waste.
Look at waste as a design flaw.
It's about reimagining waste as a resource.
Every resource gets a second life or gets as many multiple lives as possible.
Circular economy just means we have to be more like nature.
What do we leave behind, and how can we make a change to the environment we're living in?
Deep inside the Tuscan mountains stands Prato, home to the textile capital of Italy. The city doesn't just produce textiles, it also recycles them. Fabio Marceo started his own textile recycling business, continuing the family trade.
We have a long story in this business, in recycling. I think all started in the 14th century. I am the third generation in this business. I work in recycling textile because of my family. I want to be a merchant, and why not in this business that is our history and the history of my family.
The family built its business on collecting used clothes. It's a crucial first step in an ecosystem of clothes recycling that's made the town famous. Prato is said to process 15% of all recycled clothes in the world.
Twice a week come from Germany one truck full of, as they say, garbage. But for us it's not garbage, it's raw materials and recycling materials. And also every day arrive 4 little trucks from Florence. And our process here in company is to make a selection of these goods. And our main business is to take as much as possible material as reuse. Only after we think about recycling. This is the most important step of selection. That's why we have our oldest friends and employee, Paola, that work with us since 25 years ago. And all what we select here is extra quality, and this material is what remain here in our Italian market or go in East Europe market.
The clothes receive a very valuable second life wherever they end up. That's important, considering that making clothes is a highly resource-intensive enterprise. The fashion industry produces close to 10% of the world's global carbon emissions and uses nearly 100 trillion litres of water annually. That makes it the second most water-intensive industry in the world. More than 80% of all clothing finally ends up in landfills or incinerators.
Dobbiamo incominciare a cambiare dei paradigmi nei confronti del nostro pianeta, non tanto per salvare il pianeta, come molte volte viene spesso detto, ma salvare proprio noi da noi stessi. Quindi un modo virtuoso nel produrre abbigliamento rispettando l'ambiente, ma rispettando soprattutto gli esseri umani che ci vivono.
Prato's history of recycling originates from leaner times, centuries ago. Times were hard, raw materials were scarce, and people needed clothes. Prato's sensiaiolis, or ragmen of old, would collect clothes and select them by quality, texture, and weight. Then they would organize them by color and from the shreds, recycle the fabric. The same process continues today, with a little help from modern technology. While Fabio works to get clothes with a little more life left reused, Fabrizio Tessi deals with clothes that are completely spent. His workshop recycles up to 25 tons of clothes in a single day.
Alle mie spalle possiamo vedere l'impianto di carbonizzatura. L'impianto di carbonizzatura costituito da due macchine essenzialmente. Un essiccatore che toglie la parte, l'umidità dall'indumento usato e il carbonizzo vero e proprio dove è una macchina pressurizzata e attraverso acido cloridrico va a eliminare tutte quelle che sono le parti di cellulosa nel materiale. Questo perché dona all'indumento usato una maggiore solidità dei colori, elimina tutte quelle parti di cellulosa e quindi aumenta la percentuale di lana.
This is the result at the end of the process: mechanical wool. What was once the fabric of used clothes thrown away has now been given a second life.
Un prodotto che ha delle performance eccezionali nonostante sia stato prodotto da un materiale di indumento usato e quindi da un riciclo. Questo è, diciamo, è la garanzia che la filiera del riciclo riesce a produrre dei capi di altissimo livello.
Prato shows the world that it's not just technology that enables change, but culture too. This is a circular economy that's been keeping livelihoods going for centuries.
Ogni volta che noi realizziamo una lana meccanica è come un figlio che nasce tutte le volte. Un figlio che nasce e in qualche maniera va accompagnato in un percorso. Farlo maturare attraverso la realizzazione di un tessuto e quindi tutte le volte c'è sempre lo stesso entusiasmo.
Going circular means more than just making new clothes from old ones. It's also about getting as much use as possible out of them. One company in Singapore is rewriting fashion by getting people to rent clothes rather than buy them.
Aisha, this is for order number 48A, right? I need you to QC this. Okay.
In a city like Singapore, a lot of women lead very busy lifestyles and are generally quite time poor. So the platform that we provided them allow them to have that freedom to just wear anything that they choose from very varied designers from all across the world, which are designs that they wouldn't have access to usually.
Okay, so these are the trending colors.
It works like this. Customers pick their plan, starting from about $45 a month for clothes and $75 for bags. They select what they want on a catalogue, and a box arrives at their door. They return it after a month, and it goes back to a cloud wardrobe full of items that are carefully curated according to a database of preferences for styles, sizes, and occasions. The company have since set up cloud wardrobes outside Singapore, in Jakarta and Hong Kong.
It enables every piece of item that has been produced to stay within the ecosystem. A dress that has usually only been worn 2 or 3 times is right now being used 30 to 50 times within the ecosystem, really stretching the lifespan of every piece of item.
How many pieces can this bag fit? It will fit 4 to 5.
So we have facilitated over 2.3 million rentals so far, and we're very proud of that because that actually helped to save over 600,000 pieces of items not going into the landfill. It is actually a small win for us, and there's just so much more that we could do together if everyone tries out rental and really prevent the unnecessary production of clothes and unnecessary throwing away of clothes.
"10,000 kilometres away in London, another business has a different idea to give clothes a little more life. Ryan Mario Yassin is a clothes designer of a quite different sort.
I think design really should solve problems and at the same time push humanity forward so that tomorrow is better than today.
Ryan trained as an aeronautical engineer.
Morning, Arabella.
Then put those talents to a different use. He makes clothes, or as he calls it, wearable technology.
Well, how can we design for a family on Mars? You're not going to want to take 7 garment sizes up into space. So if you can have clothes that grow, that is the garment that they would take to Mars.
At university, Ryan designed expanding structures for cube satellites. Ryan's folding structures meant that solar panels could be folded into a gap just millimeters wide, and when deployed in space, unfolded into a large structure. He used those expansion ideas on Petit Plis clothes.
So the way a Petit Plis garment works is it's embedded with a structure that allows it to grow bidirectionally to custom fit a range of ages.
That's called a negative Poisson's ratio.
So what a negative Poisson ratio is essentially a material that grows along its length and width at the same time. So this is the most optimal expansion ratio for a child between the ages of 9 months and 4 years. Thus, this garment grows through 7 discrete sizes.
And when Junior outgrows the outfit, it gets passed on to his younger siblings.
Some people loved it, some people absolutely hated it. It just caused so much conversation, and that was the perfect opportunity to get people talking about waste and sustainable fashion and resource efficiency and innovation within the garment industry. All you have to do is pull horizontally and it resets the entire structure for easy care. The materials we use are from waste bottles. So we recycle the waste bottles, turn them into the fabrics. 2, the manufacturing process, it's so streamlined. So instead of creating 7 different sizes, we create 1 size, and that means more efficiency for the manufacturer. 3, what people do often these days with fashion e-commerce is they buy multiple sizes and then they return the size that they don't like or that doesn't fit them as well. And this amounts to a huge amount of CO2 emissions, and it's really bad for a company's bottom line to be able to survive. Next, you have the users. So how can you inspire users to live a better life or to also grow up to solve problems? We're speaking to the parents and we're speaking to the children, and we're trying to inspire the children to grow up to be astronauts, to grow up to be engineers and scientists, and to use design to their fullest potential, or communication to its fullest potential, to spread the word.
In terms of emotional durability, it's creating a garment which will change with you as you change.
Yeah.
They haven't stopped at children's clothes. Ryan is applying his technology to maternity wear and outfits for the elderly with mobility issues.
The functionality of color.
They also want to lease their clothes, so they have longer lifespans. Altogether, this is an antidote to the widespread culture of buying and throwing away.
Yeah, but I don't want to put my child in a garment for 2 years because that's just so not normal in today's world. But if we can make that the norm, then there's so much opportunity for that. Really, our goal at Petit Plis now is to nudge people's behavior and mindset towards their garments, to understand that their garment shouldn't really cost less than a sandwich, and also show them the potential of actually investing in the value of the garment. There's a huge potential for our garments to just add more value to our everyday lives, and I think that we should be asking more of those garment designers and that supply chain to ensure that that can happen in the future.
From my perspective, science needs to be social. Most of our science is actually funded by society. It can be knowledge, it can be technology, right? But it should be a return to societies.
Javier Fernandez and Stilianos Dritsas want to change how the world makes materials so they won't cost the earth to produce.
Is this rotating? Yep. Okay.
They're co-inventors of a fungal-like adhesive material, or FLAM. FLAM is a biomaterial. It's made of natural matter that's abundant in supply. The lab's work could herald the dawn of a circular economy of materials. Biomaterials are easily recycled, and they could be the long-awaited antidote to the overuse of plastics.
Plastic brought like a completely different concept to the table. That is the concept of I can manufacture really fast and I can manufacture very cheap. So now the things, they are not made for lasting, they are made for convenience. So after you have a dinner, you don't need to do dishes. You just wrap everything and then you throw it away. And now for us, it looks funny, it was even terrible, right? And it's not because these people was bad, right? It's because the concept of we have a limited space on Earth is true, right?
I think we cannot expect that biomaterials can completely replace plastics because they have some very useful properties, so for certain applications are indispensable. For example, synthetic plastics from petroleum can be used for applications where you need to create barriers for oxygens and water. Exactly because of those properties, common plastics cannot be recovered by natural processes. What we can target pragmatically is to deal with the overuse of plastics, right? That's a more practical and reasonable approach for the time being. And maybe in the future, if there's new forms of biomaterials, maybe we could even replace plastics, synthetic plastics. First, we're gonna create the resin or the adhesive. To create the adhesive, we need water here. And I need to add 10 grams of chitin here. We need to add the acetic acid. It will start becoming like a gel. At some point I won't be able to stir it anymore. Then we prepare for mixing it with cellulose. So after we complete mixing, then we get the material which has the consistency of Play-Doh. You can take any shape you want, and that's why it's kind of a bioplastic material.
The material is natural, and the production process mimics nature. It's done by additive manufacturing, otherwise known as 3D printing. This is almost how nature produces, with layer upon layer of material forming a final product.
This is very unlike traditional manufacturing processes where you use stock material and we cut patterns and shapes out of it, and producing a lot of waste. So in that way, additive manufacturing is very efficient about material use. This is actually very similar to how production, in a sense like assembly, takes place in nature, where material is used very efficiently, because the geometry is something that is for free in nature. But the energy to assemble these complex shapes and structures is what needs to be minimized, right? Because the resources are in scarcity. This is the relationship.
But also, more importantly, additive manufacturing is a general manufacturing technology. So you can literally, or in theory, fabricate any object. So that allows us to also decentralize the production with natural materials. And that's key because biological materials, they are everywhere. The potential of these materials that are distributed everywhere in the world and have a technology that also you can distribute everywhere in the world. So they are like a perfect match between the concept of biomaterial and the concept of additive manufacturing.
Applications of biomaterials are still in the research phase, but the prospects appear vast. Equally promising is the abundance of sources of raw materials. Chitin, one of the building blocks in this recipe, can be found within the city. That story starts here, at a suburb in densely populated urban Singapore. An unlikely place for a farm, Chua Kai Ning breeds a very useful species of flies.
Hi guys, morning.
When we began the farm, it was a bit of shot in the dark because there's no such thing being done in Singapore before, and even in the region.
Kai Ning farms black soldier flies, which feed on food waste, donated by soybean product manufacturers and beer brewers. The flies have voracious appetites and multiply by up to 500 times. They produce fertilizer from their feasts and nutritious animal feed from frozen larvae. Insecta earns part of its revenue from the sale of these products.
The word circular economy actually comprises two parts. We have circular, meaning sustainable. Everything that we do has to help the environment, has to have an ecological benefit. And the second part is economy, which means it also needs to make dollars and cents as well. in the way that we reimagine our production system, it can't be bleeding money. It has to make both ecological and economic sense.
Animal feed and fertilizer are just part of the business. Insecta is fundamentally a biotech company. Their lab activities are housed at the Institute of Chemical and Engineering Sciences at Singapore's Agency for Science, Technology and Research, and supported by Enterprise Singapore. Chief Scientist Phua Jun Wei is working on a way to extract valuable materials from byproducts of the black soldier fly industry.
So these are the raw materials from the black soldier fly industry. Inside these byproducts are loads of biomaterials that we can use for the benefit of society. We first remove all the minerals and proteins that are stuck in these byproducts, and we end up with chitin. So chitin is typically found in the exoskeleton of crustaceans and insects. From chitin, we then turn it into chitosan. Chitosan has a wide variety of uses, from pharmaceuticals to alternative foods, all the way to agriculture.
In agriculture, chitosan is used to promote seed growth and to help plants fight fungal infections. In medicine, it's used in bandages to reduce bleeding, and its antibacterial qualities make it useful for preventing infections in wounds. Because it's biocompatible, meaning it's completely safe in our bodies, it's also being researched as an efficient way to deliver drugs to specific locations. Chitosan is typically refined from chitin, which comes from the shells of crustaceans.
But the important thing to understand is that it comes from a not so sustainable source. People can say that it comes from waste because shrimp shells and crab shells are waste. But it is still a consumption of marine resources, and we know that when people make chitosan, they can actually harvest marine resources specifically for this purpose.
Junwei is working on a patented process that uses black soldier flies, a much more sustainable source. The other star product that could be extracted from the fly is melanin.
In the biomaterial industry, melanin has been given the nickname black gold. And that doesn't only refer to its value, like it's worth a few $100s a gram at the moment, but also its potential uses. Because melanin is biocompatible, it can one day be used in electronics meant to be inserted into the human body without the fear of heavy metals leaching out. Another use for melanin, which is very, very promising, is where it can help with CT scans as well as MRI scans. And one more huge use of melanin is its ability to diagnose and treat certain cancers.
Insecta is pioneering the extraction of melanin from black soldier flies. It's a discovery that promises to make melanin far more accessible. It also opens doors to exciting new innovations that could benefit mankind.
All of the technologies that utilize melanin are all stuck in the academic phase. They talk about their amazing inventions, and people will ask them, but where are you going to get this melanin from? Now they can actually say that there's an unprecedented and endless supply of melanin that could be extracted indirectly from food waste, and thereby it helps their technology stand a chance at going to market.
High-value biomaterials made from food waste and black soldier flies. Chua Kai-ning says she's proud to see the circular economy happen right before her eyes.
My grandfather was a Karang-Guni man, for one thing. So this concept of recycling waste, I guess, has subconsciously been inculcated in our family and the way we do things. So that definitely carried over to my career. So my passion, it honestly lies in waste valorization. I hate the idea that things go to waste.
What do we leave behind? And how can we make a change to the environment we're living in? The things that really affected me when I was growing up was I didn't really think about where my waste was going. But as I started learning more about the influence of my waste, my own carbon footprint, I realized it actually is not just a problem for the policymakers, it's also a problem for us as Singaporeans.
Singapore is a food paradise, but it also has a messy problem with food waste. In 2020, Singapore generated more than 650,000 tons of it. A lot of food gone to waste for a city of just 5.8 million people.
Part of our research that we're trying to do here is try to reduce our negative impacts on the environment. So that's the big picture. And why not use these humble insects who've already been doing this for millions of years? They've been converting waste very efficiently. Now, why not modify them for our purpose so that they can help us in, well, reducing our own environmental footprints?
Nalini Punyamuthi cultivates a special breed of black soldier flies. To thrive in a land-scarce city like Singapore, the flies must learn to mate in much smaller spaces.
So black soldier flies generally mate in really large spaces, about 10 times the size of this cage here. Now, through selective breeding, we've managed to reduce the amount of space that's required to establish a culture of black soldier flies. They then mate the next generations. So what we have here is little substrates that mimic food waste. So they attract the females to come there. And so when the females are attracted, then the males then have a night out. It's by trial and error. Most of science is by trial and error. And that's how we've managed to come up with Singaporean lineages of flies that can mate in much smaller spaces.
What drives the research is a vision to close the loop on food waste. Black soldier flies devour food waste, but Singaporean ones require pallets that are finely tempered.
We put it in these blue drums for fermentation. We add lactobacillus to ferment the food. This not only breaks down the food to help the digestion of the maggots, it also prolongs the life of the food, so I can keep the food for up to 6 months without going bad.
One of the biggest challenges for us is to try and use local strains of black soldier flies that can be adapted to breaking down diverse food waste. So food that sometimes might be spicy, food that is salty, which is very common with our food, and food that is rich in carbohydrates, which is quite indicative of an Asian diet too. This is basically what used to be your chicken rice, what used to be biryani is now a very homogeneous mixture of larvae and the frass. And this frass can be sifted out and can be composted to grow leafy vegetables. And the larvae can be processed into animal feed. All the research that comes out of our lab is done by graduate students, undergraduates, research assistants, and postdocs. So I'm mainly just living off their wonderful efforts. Send these samples for chemical analysis. Seeing the next generation getting excited about science and making changes that affects their own country, for instance, that's rewarding. And my little input saying that this is what we have done for our community, that would be rewarding in the long run.
While research to valorize food waste continues, elsewhere in the city, another lab pushes frontiers on tackling a growing problem with a different sort of waste. Madhavi Srinivasan is working on an environmentally friendly way to recycle electronic waste. This is a collaborative venture between Singapore's Nanyang Technological University, or NTU, and the French Alternative Energies and Atomic Energy Commission, the CEA for short. Research starts at the typically tedious and expensive task of sorting e-waste.
I'm working on the sorting of electronic components, and this artificial intelligence is recognizing different components. So it works with a simple camera, which is recognizing the shape. So they're going to be sorted in different bins, and then we can recover the different elements from the different batteries.
Electronic waste contains precious materials like gold, silver, copper, lithium, and manganese. They're mined from the earth, and supply is limited. The conventional approach for recovering these materials and recycling e-waste uses pyrometallurgy. That's cooking everything to a temperature as high as 1,000 degrees Celsius, then recovering precious materials from the melted mass. It's an expensive process, requiring big machines and large investments. It also produces toxic fumes, and some precious materials like lithium and manganese can't be recovered from the process. This lab uses a different approach. It's called hydrometallurgy.
Hydrometallurgy is a process which uses water. Rather than heat, we work with water or any solvents. So in the classical hydrometallurgy approach, what people do is, rather than using high temperature, they use concentrated acids to dissolve the batteries. These concentrated acids leaches out elements that are present inside the batteries. Our approach is to use environmentally friendly solvents, to use waste to treat waste. We also found that there is another stream of waste, food waste, which is a big concern, especially in Singapore. So we were thinking of how do we combine these two streams?
We turn to fruit peels waste because it actually is a rich source of organic acid, as well as reducing agents such as glucose and antioxidants, which can also help in the extraction of metals in the hydrometallurgy process. Initial result shows that actually there are other peel waste which may potentially be more effective than orange peel.
Singapore's research into e-waste recycling will pay off with big dividends. There's a nationwide green plan being rolled out. An energy reset calls for less energy consumed, a switch to cleaner and renewable fuels, and a big push for electric vehicles.
At some point, these EVs will reach an end of life, and what do we do about it will be the question. So if Singapore can play a part both in this value chain of e-waste recycling, extracting these materials and supplying to the neighboring countries, that would be a value creation. On the other hand, it can also be a hub for e-waste recycling, where batteries that are generated in the vicinity can be recycled, some part of it, and Singapore can be a material manufacturer producing the materials.
This lab makes new lithium-ion batteries from recycled cobalt, lithium, nickel, manganese, and other precious materials, all extracted from old batteries. Madhavi studies how her research on recycling could be commercialized.
So once we have the recycled materials, either an anode or a cathode, we bring it to this facility, and what comes out of the dry room is the final finished battery. I'm extremely excited. I think the prospect of making new batteries from old batteries is fantastic, and it really gives a very new dimension to the word circular economy.
Madhavi's research in NTU is in collaboration with the CEA. It's here in the town of Marcoule in France. This is the CEA Marcoule Centre, founded more than 65 years ago in 1955. The centre has a long history of studying nuclear waste recycling. It taps on that know-how to discover new ways to recycle electronic waste.
I'm really optimistic because we build up the future. It is very important to answer the question of the available materials. The frame of this alliance between the CA and NTU, we will take in account different kinds of waste in order to produce a new high-value product which can fit in a value chain of a new economic model, and then to develop low-impact processes for the recycling of waste.
In 2019, more than 50 million metric tons of e-waste were generated. It's the fastest growing domestic waste stream globally. Much of it is toxic. And it will grow as populations grow, and as more people can afford the gadgets that we just can't live without nowadays. Today, barely 20% is recycled.
We only have one Earth, and the amount of resource available is limited. The population increase, so at some point you'll have a crush point. And if you want to avoid that crush point, the best way is to imitate life and to go from ash to ash, from dirt to dirt, and to allow a system that is extremely effective, that consumes as little resource as possible, and whatever resource you use, you recycle.
Buildings are among the biggest culprits of resource depletion. They consume 35% of all the world's energy, and in constructing them, 40% of the world's resources. The world is on a search for a more sustainable way to build built environments, a circular way. One company in Taipei is a trailblazer in circular design.
Whether the negative ventilation...
Architect Arthur Huang co-founded MiniWiz. The outfit makes products, fixtures, and buildings, all upcycled from industrial and consumer waste. Arthur wants to show the world the unlimited potential of trash.
A lot of people talk about beautiful built environment, but what if the beauty come at the expense of toxicity, come at the expense of killing rainforests, come at the expense of blowing up a mountain just to get that piece of marble out to your bathroom? I'm educated as an engineer and an architect, so I know the importance of beauty, about mimicking nature on the formal level, on the design level, but on the engineering side, you want to solve a problem that we all collectively face. And I think that is where I think most designer and architect has to go.
The company's latest design helps hospitals in their fight against COVID-19. This is the world's first modular and pandemic-ready hospital ward. It can be assembled in less than 2 days, and almost 80% of it is made from recycled materials.
We use our engineering capability to basically turn locally collected recycled material like aluminium, recycled polypropylene, polyethylene from the medical waste industry, and also from our typical single-use bottles, and even masks, PPE that we throw away. And we want to use that to upgrade existing medical infrastructure and to create the most valuable asset in the most difficult time. The most valuable asset right now is pandemic-ready ICUs.
MiniWiz wants people to see recycled materials as things of value, to be prized more than marble, wood, brass, or any other exotic traditional material.
If consumer has that consciousness, yes, the real estate developer will follow, the government will follow, and the consumer then has to prove or help this whole process to show that there is a market demand for that. And the market demand for that, I think consumers needs a lot more education and inspirations. And I'm sure the younger generation prefer not to have marbles from Brazil. I really are confident with that.
Sustainability has become this badge that you stick on everything just to kind of give this green veil as to ensuring that it might be good for the environment. Sustainable thinking and circular thinking goes far deeper than that. It's not just about social, economic or environmental issues and people championing the environmental cause. It's also thinking carefully about space, culture and technology.
Jason Pomeroy is an author, academic and architect who's one of the world's foremost experts on sustainable design. Jason built Singapore's first carbon-negative residential building. But it's not just energy he wants to be frugal about. Jason wants to get people thinking about making the most of every single resource, even space.
How can we recycle space? How can we look at space, for instance, not just for a period of time, but 24 hours? That is optimizing the use of one thing and extending its life cycle because you've designed it in such a way to give greater meaning. It's not just about designing something for one purpose. It should be doing 4, 5, 6 or 7 things. And by having that element of flexibility and adaptability, that is truly sustainable. That is also circular thinking because it extends the life cycle of that particular product or system.
Another way to reduce waste is by simply not demolishing buildings. Since the 1970s, Singapore has taken steps to conserve its architectural heritage. The practice has done much to enliven the city's culture.
We just need to be conscious that circularity is about designing out the waste and making sure that we can really retain some product or system for as long as possible without changing before we start thinking about what other uses can come out of it. The colonial shop house is a wonderful example of how the bricks and mortar of this heritage type structure has stood the test of time, from a place to live and work to sometimes today being used as a bar or restaurant or a micro office or even a residence. That, to me, is the ability to try and show how adaptable a structure can be and therefore how the circular thinking can take root.
Elsewhere in the city, a new building demonstrates circularity in a different way. It is on the grounds of the National University of Singapore's School of Design and Environment. This is Southeast Asia's first zero-energy building. Lam Ki Po is the dean of the school. He's also served as building performance consultant for several award-winning projects in Singapore, China, and the United States.
A lot of these common places need not be air-conditioned. We can actually provide those spaces with natural ventilation and natural conditioning. And that, again, will save a lot of energy. In this space now, the temperature is about 26 degrees Celsius. The indoor air quality here, the CO2 is just like outside. Now, the hybrid system combines traditional air conditioning with ceiling fans. And it is this combination that enables us to have the comfort condition whilst not making the air too cold, and therefore saving energy.
The building generates its own power. Over 1,000 solar panels cover its roof, providing enough electricity to power over 100 apartments for 1 year. In recent tests, the building has actually surpassed its net zero energy target, generating more energy than what it used. It offers learning points for new developments in Singapore.
You just cannot have an architect design a nice building. You cannot just have an engineer design an efficient engineering system. We need to coordinate and integrate these multiple disciplines to come up with creative and innovative solutions that will tackle these very complex problems. We need to be much more conscious and conscientious about our relationship to the natural environment and to the ecosystems, and learn to live in a harmonious way and not try to do funny stuff.
In Singapore, urban landscapes are being reimagined.
These pinks are picking up the adaptive reuse buildings. Is that what that color is meant to indicate?
Nirmal Kishani and Swinal Samant are compiling ideas from a recent project to redesign an industrial estate. The project was supported by Singapore's JTC Corporation.
What is the legend of this building?
This was the site under study. Sungai Kadut is one of Singapore's oldest industrial estates. It houses factories, warehouses and workshops built in the 1970s, which played a key role in Singapore's industrial growth.
The truth is, we don't know exactly what the future is going to bring. The kinds of industries, the kinds of businesses that an estate like Sungai Kadut will hold in 10, 20 years from now may not have been imagined yet. So how do we plan for this? How do we delimit the possibilities?
Okay, so we see our waterfront as a way to celebrate the industrial heritage.
Studio discussions like these bring up interesting new ideas on how industrial sites could be circular and, as a result, more efficient.
Tell us how the logistical systems and automation plays a part in this.
Redefine our circularity in terms of movement of resources within the building levels.
For a start, energy, logistics and technology streams flow in a closed loop, so resources move easily between one industry and another. That's the hardware. For the software, it's about having overlapping industries, so waste from one industry becomes a useful resource for another. In this way, synergies across the industries are created, work becomes more efficient, and the district more vibrant and livable.
So in the old Sungai Kadut, the landscape is monofunctional. It's factories with no amenities, nothing other than a place to work. In the proposed Sungai Kadut, we introduce shops and amenities and exhibition spaces and vibrant waterfronts. There are second-hand markets and farmers' markets.
Spatially, the master plan is subdivided into 3 zones. They are the factory in a forest, the industrial incubator, and the emergent village. The idea is to have a high-rise factory that is vertically stacked, with solar panels and an agrotech farm on the upper levels. On the lower levels are residences, workspaces for creative industries and industrial production. Underground, there's a large basement, which forms the logistics hub of the estate. That leaves space on the ground freed for the entire community to enjoy.
Instead of having a building that is all factory, we have buildings that are multiple users. They are multi-layered with different programs, and the proportion of these programs changes over time.
Not all ideas from Nirmal and Swinal's design studio might make it to the eventual plan, but a rejuvenated Sungai Kadut could herald the first steps towards a reimagining of manufacturing and an embracing of circularity in a big way.
Singapore will get an economic boost because it has new businesses and innovation in manufacturing. Singaporeans will have new places where they can work and they can play and they can see and they can learn and they can make and buy.
It can be a very good model that champions new industries and the way in which we develop our industrial landscape and bring in neighborhood planning within those industrial landscapes. And in doing so, we address the very important issue of waste in our environment.
The biggest win, perhaps, is that as a nation, we managed to reduce our impact on the planet.
Progress on that mission has been made in different ways in different parts of the city. This is a black soldier fly facility, and it's manned by volunteers, mostly residents in the area.
I actually signed up out of curiosity, wanted to find out how this small little thing can help to break down food. At first, I was not very comfortable with them. But after a while, you find that they don't bite, the larvae don't bite, they're harmless. Quite cute if you look at them. So after a while, you get used to them, yeah.
I live here in Block 143, and I'm basically retired. It gives me some way to pay back the community, you know, to do something for the community.
Food waste gets donated by residents every morning. It's welcomed by the larvae. They'll eat up to 4 times their body weight in a single day.
I can tell you for this community, at least since the project has started, more than 1,000 kilograms of food waste that would have been burnt has now been repurposed or given a new value. So that has been converted into frass, which currently is being used to supplement vegetable growth in the vertical garden.
They love the food, I guess.
I mean, it's so rich in fats, and they're getting good food.
You see?
We've also produced animal feed for the tilapia that are now growing strong and plump. I think it actually kind of brings us back to where we came from, because that's how a lot of our community started, right? When we had agriculture, we would produce something, and then we would take the leftover to make something else. That's how kampongs existed, and kampongs actually were one of the more sustainable models. But now going towards an urbanized environment, we've kind of lost where we came from. So this way, it kind of brings us back to our sustainable roots. And it also, I think, educates us on our own behavior, how we can change our own practices so that we don't leave behind a planet that is worse off for our offspring.
The circular economy unlocks bold new opportunities for mankind to innovate, thrive, and move the needle on climate change. Innovators, enterprises, and whole communities are closing the loop on production and waste. They're building a more sustainable future for the benefit of generations to come.